Okay, let's continue with number 5. This is section 3.2, where we are graphing polynomial functions. On number 5, we have the type where we have to factor it ourselves. Let's start off by factoring out what they have in common. They have an x squared in common, which will leave behind an x squared, a minus 6x, and a plus 9. I can factor the type 1 trinomial a little further into x minus 3 and x minus 3. I'm not going to show the process for factoring at this point in the semester, but you can factor it, or you can find the zeros using the quadratic formula. We have x squared. I'm going to go ahead and rewrite that as x minus 3 squared. Remember, the multiplicity is actually the number of times that 0 occurred. I'm going to solve the x squared for the 0. That's going to give me an x of 0. Because there are 2 of them, remember my little saying, don't even touch me. So that's going to be a touch. And this guy, when I solve it by setting it equal to 0, is going to give me an x of 3. Because there were 2 of those, or if you solve both of these and get 2 of them, or use the quadratic formula and you've got 2 of the 3's, that's also an even number or a touch. Now we're going to put those on a number line in order, smallest to largest. I know that my function will touch at both of those, but not cross. Now I'm interested in where does it start, above or below the axis. I'm going to plug the negative 1 into the original function. We're going to get negative 1 to the 4th minus 6 times negative 1 to the 3rd plus 9 times negative 1 squared. The negative 1 to the 4th is negative 1. That's going to be minus 6 times a negative 1 plus 9 times a positive 1. 1 plus 6 plus 9 is a positive 16. Because it's positive, it tells me that my function starts above. I'm going to come down and touch, come down and touch. Let's look at number 6. Number 6 is the same type of question, but it is already in factored form for us. So we have that part done for us. They're a little quicker. We're going to start off by solving each one of these for its 0 by setting it equal to 0 and solving it for x. We're going to get a negative 3. Because its multiplicity is 1, it's odd, it's going to cross. This one is going to give me, let's see, after setting it equal to 0, an x of negative 1. That is also an odd multiplicity, another cross. The x plus 4 is going to give me an x, or 0 or an x value of negative 4. It's got a multiplicity of 1, which means it will also be a cross. Now we're going to put it on a number line. Remember to put your numbers in order from smallest to largest. You can't get the right answer if your number line is wrong. All right, now we just need to figure out whether we start above or below. So we're going to plug a negative 5 back into the original equation. Negative 5 plus 3, negative 5 plus 1 to the 3rd power, and negative 5 plus 4. Negative 5 plus 3 is negative 2. That's going to be negative 4 to the 3rd power, which is a negative 64. That is going to be a negative 1. We have 3 numbers that are negative, that are being multiplied together, so the answer is going to be negative 128. Because it's negative, we're going to start the function below the axis. All of these were crosses. So starting below, we're going to cross, cross, and cross. Let's look at number 7. Sorry, I'm going kind of quick. I'm trying to get these finished. If you need it slower, pause me. We're going to do long division. The number we're dividing by is the x minus 2. Remember, print your review on Blackboard so you can see the problems and directions that are associated with these questions. I'm doing long division, so real quick I'm going to put the function into the long division box. And then I'm going to start. When you do long division, you really only look at the first term in each polynomial. What do you need to multiply x by to get 6x cubed? 6x squared. Then you distribute. 6x squared times x is 6x to the third. 6x squared times negative 2 is minus 12x squared. And then we change the signs. Combining like terms, our third degree terms are going to cancel. We're going to end up with an 8x squared. The rest of it comes down because there's no other x's to combine that with and there's no other constant to combine that with. Then we get to ask ourselves the question again. What do you need to multiply x by to get 8x squared? 8x. 8x times x is 8x squared. That's what we wanted to happen. 8x times 2 is minus 16x. And we change the signs. Now we can combine like terms. The squared terms cancel. The 16x and the 16x becomes 32x. And I bring the negative 1 down. There isn't anything to combine him with. Looks like it'll go one more time. What can you multiply the x by to get 32x? 32. 32 times x is 32x. And 32 times negative 2 is negative 64. But we change the signs. Binding like terms, the 32x's are going to cancel. That's what we wanted to happen. And we get 63. That's our remainder. Remainders are always added on and put over the divisor. Look at number 8 right next to him. For number 8, the divisor is x plus 2. I'm going to put that on the outside of the long division box. Inside the long division box, we have 8x squared plus 5x minus 7. Now we ask ourselves a question. What do we need to multiply x by to get 8x squared? 8x. 8x times x is 8x squared. 8x times 2 is 16x. And we change the signs. Now we're going to combine like terms and see what's left. The squared terms are going to cancel. We're going to end up with negative 11x after we combine the x's and a negative 7. Looks like it'll go one more time. In order to get the x to look like a negative 11x, we multiply by negative 11. Negative 11 times x is negative 11x. Negative 11 times 2 is negative 22. And we change the signs. Combining the x terms, they cancel. And negative 7 and 22 add up to 15. That's our remainder. Remainders are always added on and written over the divisor. That's the answer we're looking for. Let's do our synthetic division. So number 9 on the review. For synthetic division, I'm going to start off with, on number 9, setting our divisor x minus 2 equal to 0. So I'm going to end up dividing by 2 when I solve for it. Now I'm going to put this into the synthetic division box. It has to allow for 2 rows of numbers. I'm going to put my little cheats in so that I don't lose any position. I need a third degree term, a squared term, a plain x term down to the constant. If anything is missing, we use placeholders of 0. We have a 1 as a coefficient for the third degree term, a negative 6, a 3 for the x term, and then 11 is our constant. For synthetic division, all we do is bring the first one down, multiply right in the next available position, and add down. We're going to multiply, write it in the next available position, and add down. Multiply, write it in the next available position, and add down. Our final answer has dropped a degree, so it goes from a third degree polynomial to a second. I get 1x squared minus 4x minus 5, which means this guy is our remainder. Remainders are always added on and written over the original divisor. This is the only answer that gets full credit. Number 10. Start with the divisor, setting it equal to 0 and solving. This time we're going to divide by 3. This is a fourth degree polynomial that we're dividing into, so I'm going to need a fourth degree position, a third degree position, a squared term, a plain x down to the constant. If anything is missing, we use placeholders of 0. Fourth degree term is 1. Third degree term 0. Second degree term 0. Plane x 0 down to negative 81 are constant. We're going to bring the first one down. We're going to multiply, add down. Multiply into the next available position, add down. Multiply into the next available position, add down. Multiply into the next available position, add down. Now this one divided into it evenly, but we still have to drop a degree when we write our answer down. The final answer is x to the third plus 3x squared plus 9x plus 27 and no remainder. I'll see you in the next video.